Hi, my name is Benoît Gélin. This paper is entitled Visuo-haptic Illusions for Motor Skill Acquisition in Virtual Reality. My co-authors are Gilles Bailly, Sinan Alliot, and Corentin Duboc. In a nutshell, Visuo-haptic illusions are a very famous interaction technique in virtual reality. Several studies show that visuo-haptic illusions favor user experience in VR. In this talk, we investigate whether visuo-haptic illusions also favor skill transfer. And the answer is yes, visuo-haptic illusions do favor skill transfer. Okay, this presentation is divided into three parts. I will start by talking about a visuo-haptic illusion in a particular and in particular one called hand redirection. Then I'll define skill transfer and finally describe the empirical study we ran. VR is both effective for entertainment and as a training tool. It allows to easily immerse a user in a different environment, interact with virtual objects, and move around. However, it lacks rich haptic feedback. The controller, despite being an easy tool to interact with a virtual environment, can't provide realistic haptic feedback beyond vibrations. This lack of haptic feedback can have an impact on immersion, but also skill acquisition. Adding haptic feedback in VR is difficult to implement. Traditional grounded haptic interfaces are cumbersome, they have limited workspace, or require users to hold a handle, which doesn't foster natural interactions. They are also often expensive. A promising alternative is to use tangible objects called props. Let's explain why and how. Consider a simple scene with a single virtual object users can interact with. One simple and effective way to increase immersion is to use a similar real object in the real world, so that when users touch the virtual object in VR, they feel exactly the same thing in the real world. However, when we have several virtual objects, it requires several real objects. This can quickly be expensive and not very appropriate for complex environments. One solution is to use a single real object for several virtual objects. This approach is called hand redirection, one example of visuo-haptic illusion. Whatever virtual object a user wants to touch, their hand is shifted toward the real object. The user ends up touching the desired virtual object while their real hand touches the single real object. How does it work? Let's superimpose the virtual and real environment. We can see that the real hand in white always touches the real target, while the virtual target in black touches all virtual targets. The main advantage of haptic redirection is to reuse a single prop for multiple virtual objects. When virtual scenes are complex with many objects, they allow to simplify the real setup by using less props than virtual objects. It is cheaper and simpler. Moreover, as users are touching and manipulating real objects, this approach provides a rich haptic feedback. What about hand trajectory, which is important when learning a motor control task? Let's look at them. This is a curved trajectory following both the virtual hand and the real hand. The trajectory is curved because the user has to correct themselves in order for the real hand to reach the real target. Without hand redirection, we can see that the trajectory is very different. Obviously, the user follows a straight line to the target. So the hand redirection technique has several advantages, but alters the hand trajectory. This might be a problem to learn motor control task. Before studying this question, let's define skill transfer. Transfer of learning is the study of the influence a previously learned task has on a new task. In other words, how does practicing the previous task influence the performance on the new task? A way to measure this is to compare the performance on the new task with practicing and without practicing. In general, we assimilate the previous task as the training phase, typically in VR, and the new task as the test phase, typically in the real world. It is common to have a rest time of 1 day between the training and the test. Let's see what the performance would look like. By plotting the task completion time for test only without training, we obtain this progression curve. The curve decreases, which shows learning. Now, let's add the training plus test. As you can see, after the training, the performance is better in this case. The transfer of learning depends on the performance at the start of the test. When the performance is greater after training, we call it positive transfer of learning. But this is not always the case. Sometimes the performance after training can be identical. We say the transfer of learning is null. This can happen when the training is too different from the test and doesn't have any influence on the test task. It can even be negative. This happens when the training task interferes with the test task. So what happens when using hand redirection during the training phase? Coming back to the trajectories followed by user in VR with Visuo-haptic Illusion or in the real world, the difference in trajectories could interfere with the transfer of learning as the user may not learn the same task. So our research question is, how does Visuo-haptic Illusions influence transfer of learning in VR? To explore this research question, we concluded an empirical study. We focused on motor skill learning. We chose a task that reflects many real-world tasks, such as assembling a mechanical piece. This task can benefit from haptic feedback in VR. This is why, in this experiment, the participants performed a multi-target pick and place task, as it is quite representative of these manual tasks. We placed the cubes in the scene so that the user would interact in the entire desktop environment. We used the well-established protocol to study skills transfer. The user study happened in 2 consecutive days. The first day is the training day and the second day is the test day. We had 3 conditions. The first one is the test-only condition. Participant had only 1 day and realized the task in the real world with 6 cubes. The second condition is virtual training plus test. Participants trained in the virtual world the first day and were tested in the real world the second day. 6 cubes were also visible in VR, like during the test day. However, in the corresponding real setup, participants only interacted with a single physical cube. We used the hand redirection illusion to fool the participants into reusing the same physical cube each time. How does it look? Participants had to grab each cube and place them on the appropriate target in succession. We clearly see the hand redirection here. In the virtual scene, the virtual cube reaches the target location, here is the location 1, but on the physical scene, you can see that the cube does not reach the target location. The precision of placement was around 3 centimeters from the center of the target and 10 degrees for the orientation. Finally, we have a last condition where the users train in the real world with 6 cubes. As it is exactly the same as the test phase, it is an upper bound. So it is interesting to compare how far the condition with the hand redirection is from this one. On to our results. We had 2 kinds of results, those related to skill transfer and those related to user experience. For our data analysis, we plotted for each repetition of 6 cubes forming a block, the completion time during the test phase. The curve for the test-only condition decreases with the number of blocks, which shows that they improved at the task. Both trained groups performed similarly during the entire test phase, and both were better than the test-only group. This shows that the transfer of learning is positive. The percentage of transfer for the real training plus test group was 82%, which is slightly higher than the virtual training plus test group at 78%. We observed no significant difference between those conditions. We also compared the dynamic time warping for each condition in the test phase. We averaged the values for all blocks of the test phase and found no significant difference between training groups. We also analyzed user trajectories in the horizontal plane for the virtual training plus test group. At the beginning of the training, the trajectories were erratic and became more stable at the end of the training and during the test. Onto our user experience. Participants usually did not notice the illusion despite our high amplitude of redirection. Only 2 out of 12 participants noticed the illusion, and they told us they were not bothered by it. On the contrary, they were very enthusiastic about it, and in general, all participants felt comfortable with the illusion. Our findings are the following. Hand redirection had very little effect on the transfer of learning. Indeed, we found no significant effect between the trained groups. Participants generally did not notice the hand redirection illusion despite using a large amplitude of redirection. This is why we encourage the use of Visuo-haptic illusion for motor skill acquisition, as they do not seem to interfere with motor learning and they are very practical. They allow to make learning VR scenarios for cheap and with high modularity. Furthermore, designers can use a high amplitude of redirection when users are not told about the redirection beforehand. In the future, we plan to further explain these results by testing an additional condition doing virtual training without Visuo-haptic illusion. This would allow to determine which factor between VR and the Visuo-haptic illusion has more impact on the transfer of learning. It would also be interesting to reproduce the study with other Visuo-haptic illusions than the hand redirection, such as pseudo-haptic or redirected walking. Thank you.